Introduce the next speaker, Matt. Hey, Matt. Our next speaker is Matthew Anderson from the Idaho National Laboratory. Matt is part of the high-performance computing group at Idaho National Lab with a specific focus in supporting university and industry users. So he's a great person to work with. I've been interacting with him over the last 2 years. And he would be speaking about MVAPICH integration for PBS Pro. So without further ado, I'll hand over to Mark. Matt, thank you.
Can you hear me okay?
Yes, and I can see the slides too. Perfect, thank you.
Let me see if I can get the slideshow started here. Okay, so hopefully you can still hear me and see me. If not, ping me.
Yes, I can see it. Thank you.
About MVAPICH integration for PBS Pro, and the summary for this talk is from MVAPICH 2.3.5 and on, it's all there. And that's really thanks to Hari. So this is a success story for us. We've never participated in MUG before, but it's kind of fun to chat about some of our adventures and share this particular success story. So just a little bit about Idaho National Laboratory. We don't host leadership scale systems here. We're kind of down in the trenches in mainstream. Our users we've got a lot of industry users. We support the nuclear power industry and do a lot of work with nuclear energy. And so the blue line is just a track of the HPC systems we have hosted at Idaho National Laboratory. The red line is the number one in the top 500 list. And so we're always a couple years behind the leadership scale systems. We operate at about 150,000 cores. We have thousands of users and over 1,000 active users. Essentially, we're on a couple years behind the leadership scale systems and focus in the mainstream. So we don't have a lot of leadership job scale runs going on, but we do a huge amount of work in supporting industry. So here's a quick overview. About a little over 50% of our users are national laboratory users doing research into nuclear energy. About 20% of our users are university users working in support of fuel characterization, again, nuclear energy type work. And then 22% of our users are industry users. These are active users, about 1,100 users right now. We support 3 petaflop scale systems, overall about 9 petaflops, if we count all our smaller systems as well. Falcon, about 35,000 cores, Limhi, about 20,000 cores, Sawtooth, 100,000 cores. Our job, we have a lot of oversubscriptions, so we have, for every job in the queue, we have about 2.3, 2.4 jobs waiting in queue. We delivered over 1 billion core hours last year. So there's a lot of work, and most of these are kind of smaller jobs, under 10,000 cores. And everything we support is with, we use PBS Pro. So about a year ago, what we've been doing in the past is, of course, when we configure MVAPICH, we specify the scheduler to be PBS, and we started to discover, we discovered the Hydra configure scripts. It always looks for libtorque. Now the manager library for PBS Pro is libpbs. So for years, our solution has just been, well, we just hack the little script there, and everywhere we see the configure script, everywhere we see ltorque, we replace it with lpbs, and we're usually good to go. However, we discovered that didn't work in the most recent release of PBS Pro, again, about a year ago. So we started exploring a little bit and got in contact with Hari. Now, why do we care about tight integration with PBS Pro? You can, of course, configure MVAPICH with PBS Pro, and it'll work, just the default settings will work right out of the box. What we like to do, we have so many users. Our users tend to run things out of memory. They tend to use really high memory jobs. We're not really a GPU shop. Almost all our simulations live on the CPU. And so we like to be able to keep live track of the memory usage of our users. And so if they give us a job ID, we can quickly look up what their memory usage is on the actual node. So every single node, we can keep track of the memory associated with a particular job ID. And we do that principally just to be able to keep a better eye on our users and be able to assist them in meeting their memory requirements. That's only possible with MVAPICH if you tightly couple it with PBS, or PBS Pro in our case. And so that's what really motivated this. We're just trying to keep an eye on users, and especially industry users tend not to be the most sophisticated HPC users. So for them, like SCR would be a completely novel idea. They've never heard of it. The industry users tend not to be very sophisticated, and we tend to see a lot of problems and try to have to manage those jobs a little better. And so that's why we really like to tightly couple things with our scheduler. We can easily keep track of the memory usage. So just to kind of give you a perspective, MVAPICH uses on our system since January 1st. We see we still have a lot more usage on the older buggy version. The version is not, we kind of hacked a couple with PBS 2.3.3. 2.3.5 is the new standard that we're using for all of our Moose framework simulations, all core simulations, everything's going through MVAPICH 2.3.5. We do have a lot of OpenMPI users and Intel MPI users, but mostly in the context of density functional theory type simulations. So the ones that are really driving nuclear energy are actually the MVAPICH simulations on our systems. And this kind of gives just some perspective of the distribution who are working on the quantum or the chemistry applications, and which ones are actually working on core simulations and transient reactor behavior. So what does drive MVAPICH usage on our systems? It is the Moose framework. The Moose framework is a multi-physics object-oriented simulation environment. It consists of a bunch of herd animals, and so they all have animal names like bison or raven, and they have to do with simulating particular aspects of a nuclear reactor. And they are built upon, Moose is built upon PETSI and LibMesh. LibMesh, of course, being developed by Ben Kirk at NASA. Almost all development, any development of LibMesh now is actually occurring at Idaho National Laboratory. And so these are the tools that, the tool frameworks and the tools that are only using MVAPICH right now. They're not using any other MPI framework. So this is what drives almost all MVAPICH uses on our INL, on our INL HPC systems. So what's the main story? Well, we wanted to track usage for each process inside the PBS log on every single node. So we get a CPU percentage, we get a memory percentage, how much memory they're using. Typically those logs are stored in VARSpool PBS, and we want to make that MVAPICH is tightly coupled with PBS Pro. That means it's actually able to find libpbs.so, and it's actually calling that instead of trying to call PBS attach. And so we're directly linking with the PBS task manager. And so this was implemented in MVAPICH 2.3.5. Hari did that. We attempted to do it. We got about 90% of the way, but we broke MPI abort when we did it. And so why do we care about this? PBS Pro and OpenPBS 2 has a script called PBS DTJ. And that will actually go out and parse the appropriate logs for only the job in question. And we use that heavily to keep track of our how our users are, the memory usage for each particular job. Here's just a little particular overview of LULISH. This is the Livermore Unstructured Lagrangian Eulerian Shock Hydrodynamics micro benchmark. And I just ran a couple of our systems, Falcon, Limhi, and Sawtooth, ran a couple different versions of, let's see, OpenMPI, Intel MPI, and MVAPICH on Falcon, Limhi, and Sawtooth for each of these systems, for each of these MPI versions. And yeah, MVAPICH is the best on our biggest system, Sawtooth. That's about 100,000 cores. Out to about 10,000 cores, just a little bump in there between 10 and 20,000 cores. We're working to get that down again. But yeah, in general, of course, most of our jobs are running under 10,000 cores, and these are directly supporting industry. LULISH, in terms of LULISH performance, does match closely a lot of the behavior of the Moose framework, so we kind of use it as a good benchmark for understanding how well the systems are performing. And just on the right, this is our latest Mpi Latency Test for MVAPICH 2.3.6. Just kind of gives some perspective on the type of performance. So we're very happy with MVAPICH, and especially the nuclear energy industry is very happy and leveraging. MUG may not have known that, but yeah, the nuclear energy industry does heavily use MVAPICH and actually only uses MVAPICH for the simulations, especially in terms of core simulations and transient behavior. Along the lines, as we were doing the testing and making sure we could get very tight coupling with PBS Pro and MVAPICH, we came across a couple memory leaks too, a couple memory problems. And so it started we worked closely with PETSI and, of course, our own libmesh developers to make sure we could sort this out. This is actually how we configured MVAPICH for PETSI and libmesh. I thought I'd share this just to make it very explicit how we configure MVAPICH to be able to get best performance we can, as well as to support the various modalities of PETSI and libmesh. And yeah, along the way we ran Valgrind on it, found some problems with 2.3.5 and our tight integration. We ended up missing a bitmap free command in get socket bound info. So that's been implemented in 2.3.6. So the good news, you don't have to do anything. All this is the bug fixes there. The only comment we had was that we did see still other Valgrind issues in MVAPICH. They seem harmless, but it sure makes it a lot nicer when we can get Valgrind really, really clean for when we're trying to find problems. So 2.3.5 was released with very tight integration for PBS Pro, enables us to keep track of in all PBS logs the memory and the CPU usage, and then the 2.3.6 fixed our little HWLock free issue. So conclusions. The Moose framework really does only relies on MVAPICH. It involves libmesh and PETSI, so we do have a lot of PETSI developers, and the libmesh developers live here now, that care a lot about MVAPICH and getting the best performance we can get out of it. And these have direct impact on industry. 2.3.5 and later has tight PBS Pro integration. So for those running PBS Pro, this makes life very, very easy. And then the Valgrind issue 2.3.6 released for MPI all reduce. It was fixed for MPI all reduce. Many other Valgrind issues in MVAPICH, they do appear harmless. If these can be cleaned up, it'd make it easier for us to catch problems. So just a little success story. We're very happy, and of course, this work was done by myself and Peter Sebel here at INL, and Hari, who actually helped us sort out our MPI abort problem when we were doing the tight coupling with PBS Pro. So that's all I have.
Thank you, Matt. Thank you for your talk. I appreciate it. So I have a few questions on Slack here.
Sure.
So is the Moose framework, okay, by the way, I didn't know that we were actually supporting the nuclear industry.
Little did you know, right? Oh, you should see the simulations. They're really, really cool.
Okay. Oh, wait, I wish I could see them. I'm pretty sure this is fairly classified.
It's not. No. Nuclear energy. This is nuclear energy.
Okay.
And so you can look in the nuclear energy journals. There's a huge amount.
Okay.
There's actually the most recent article. There's a nuclear engineering journal that features. We were on the cover. The simulations for Moose, and those were using MVAPICH. So,
okay.
So,
like pictures always are worth 1,000 words. So I should definitely look into that. I was blissfully unaware of this. Thank you. I appreciate it.
No, that's classified. It's published. You can look at it. So it's really good stuff. And that was all using MVAPICH.
Awesome. This is great. Thank you. So is the Moose framework publicly available for us to play around with? Okay.
Absolutely. Yes, absolutely.
Is it in GitHub somewhere?
Yes, it's on GitHub. Just Google Moose framework and you'll find it. You may have to put INL afterwards, but it should come up with this Moose framework. Yeah.
Okay, awesome. So the next question was, do you have any idea of the communication characteristics of this framework? As in, is it mostly using point-to-point communications or collectives or?
Well, that's a good question. It is. There are a lot of collectives in it, so we do care a lot about how MPI all reduce performs. In general, it's dynamic and adaptive, right? So this is, adaptive mesh refinement is going on in there. So the communication patterns change quite a bit depending upon the physics. They're going to be driven by the physics of, the temperature of the core and other things going on in the actual simulation. Okay,
that's very interesting. I will definitely play around with this. So one more question here. In your set of optimizations, I saw that you were setting lazy mem under register equals 0. Was there any particular reason? Did you guys hit any validation failures when that was set?
We had trouble. We were using, that was motivated by some test with gperf tools.
Okay.
And so that's what that was the reason why that was driven. I don't remember all the details of what that was. Of course, this is a very empirical process, right? As we explore all these different modalities. The reason for that was to enable better integration with gperf tools.
Okay. Okay.
And I don't remember exactly why.
Okay. Yeah, I will definitely sync up with you offline about some of these things. These are like very interesting. We'll try to add the MOOS framework to our internal testing. So as Dr. Panda mentioned, we have a very detailed internal testing framework. So if you could let us know what all memory leaks or what all valgrind messages that you're observing, we can definitely try to fix them, and we'll add the MOOS framework to our internal testing so that we catch any issues before you hit them.
Yeah, they look harmless, and the valgrind stuff is harmless that I see in the warning messages.
Mm-hmm.
But just when there's something nefarious like that HW lock free that was missing, it just took a lot of parsing to be able to get to that.
Right.
It's really nice to be able to run valgrind and have no error, nothing. Okay.
Obviously, yeah, that's what we always aim for. So when we make a release of master, we always run a lot of benchmarks, make sure that there isn't any memory leaks from those benchmarks. So it is, basically, I nitpick. So the students know that. So memory leaks are not a thing that I'd like to have. So please let us know. We'll definitely work with you to get that resolved for the next release. So I think I see some questions on chat. Okay, no, that is just Adam saying congrats. So Adam has this question. He was curious about the need for the homogeneous cluster setting.
Well, again, we only run CPUs. Our codes aren't GPU enabled. They'll probably never be GPU enabled just because of the structure and nature of them. It just takes so long. It's software engineering, so that's why.
Yeah. Adam, I can add another point to that. So Adam, as you know, remember the work that we did with startup, we need to exchange a lot of InfiniBand endpoint address information. So that exchange takes a lot of time because it goes over the PMI protocol. By setting this homogeneous cluster flag, we are able to optimize some data movement that takes place at that time, which significantly improves the job startup performance. So that is one of the reasons that typically why we always recommend that being set. And the latest version of MVAPICH 2 prints a very big warning message saying that, hey, your cluster can set this. If not, please set this, so that people pay attention to that. So yeah, Adam, you can feel free to unmute yourself and talk.
Oh yeah, thanks. I just realized I could maybe do that. But yeah, I remember looking at that years ago, and yeah, I guess we never sort of finished it. But I know one of the optimizations we added was a very cheap way to sort of determine that homogeneous value. But it wasn't going through the PMI method. But
yeah. So now that PMIX is coming on board, maybe I'll try to sync up with Catherine. So Catherine Moror is leading the PMIX effort. So I'll try to sync up with her, and maybe we'll see if we can push our ideas in there, Adam.
Yeah, and the other thing that I remember with this was it would have, is there a configure option to set that when you build MVAPICH? Because usually it's something the person knows and they can just configure it into the build.
Not right now, but I can add that. So let me create a ticket here to make sure that that is available with the next release. Thanks, Adam.
Okay, thanks.
Yeah,
the less the user has to set, the better in general, just because it's...
I agree. I completely agree. Yes. Yeah, I completely agree. So the thing is, some users are extremely smart like you and Matt, who know what exactly they want to do, and they know this is the variable and they do it. But a lot of users are, let's say, more in the beginners category. So for them, we want to make sure that everything works. So that's why the warnings are there. But yes, Adam, we'll add a configure flag next time. So there is a configured flag called enable Lawrence Livermore specific optimizations. So for advanced users like Livermore, there are a bunch of things that that one flag will set. So Adam, we'll add this one to that.
Okay, thanks.
No, I was not kidding about the environment, the flag name. It actually says enable LLNL optimizations. I added it. So I'll add that to this one.
Yeah. I feel honored that we have our own flag.
You've been working with this for over 2 decades now. Come on. I think that is about all the questions there. Thank you again, Matt. That is a lot of useful information. I really enjoyed the talk, and I'll be bugging you going forward. So